All right, this recording is intended to introduce you to the semester project on a mechanical punch press. You would have to do kinematic calculations, run some force analysis, and then select the motor, a belt and sheaves for the belt, a pair of sheaves, and then size, shaft, calculate a pair of gears, and do mechanical drawing, detailed mechanical drawing of the intermediate shaft of the press. Okay, so I have the this cover page will be made available to you. Pay attention to the grading scheme here. There are 25 points just for formatting. Please read carefully. Make sure to include the cover page, of course, filled out with your name and who you collaborated with. Everybody has their own values to work with, so it doesn't mean that you will submit the group project. It doesn't mean that there will be two project reports identical. If you check the syllabus, you have to submit a midterm project report and the final project report. Note the points for conciseness. Midterm project reports include steps 1 to 11, and then the remainder steps, which are actually 17, so I need to make an update, will be for the final project report. This is very time consuming. It's also used, the results, scores obtained by students on this assignment is or are used as an assessment tool for program accreditation, ABET accreditation. Okay, so what you will have to do is to choose your own values. This table here with rows 1 to 8. So first you select the material, check 1, that you will be punching hole through. Thickness, you have some recommendations here on the values, and this will be the crank RPM at 7. You choose the RPM. So number of punches per minute is the crank RPM. Okay, so this is a kinematic diagram. It shows the slider crank mechanism. This is the punch that penetrates through the stock. There's the crank length, there's connecting rod length. It's not a centric mechanism. You need to choose a slight eccentricity, and it moves vertically. Slider moves vertically, not horizontally. So please make sure that the analysis that you're doing and figure that I'm seeing is for this kind of orientation of the crank slider mechanism. To the left, you see schematics of the electric motor. This will be the sheave on the motor shaft. This is the sheave on the intermediate shaft, the one that you have to calculate, which has a pinion attached to it, and the pinion meshes with the gear, which is moving together, is assembled with the crank of the press. I have here some photographs. This one is the most relevant. It appears to be a CAD drawing of some sort. I don't know how they got this translucent chassis of the equipment. So the electric motor, and it's right above. You have to specify it at the given angle so that you can practice a bit extra when sizing the shaft. With reference to the solid mechanics or machine design, that would be a better name for this class, the solid mechanics class. Okay, so you have the motor, and it drives this intermediate shaft. Again, this is the one that you'll be calculating, and it has a large pulley to it, and then there's the pinion that rotates together with the shaft and with the pulley, or rather this large sheave pulley. I'm saying it now. So one of these presses has some clutch is included to where if the motor runs or motor running continuously, you actuate the press only at a given time. So you engage a clutch and makes the punch cycle. But that's not something for you to worry about. You're just assuming that it's continuously driven. And then the gear, this large gear, which acts as a flywheel, and you have to size or calculate the required moment of inertia of the flywheel, mass moment of inertia, and then the crank slider itself. It doesn't show the punch itself. You can see here it uses a spherical joint, and the crank is actually maybe not visible here, but on this figure, the crank is just an eccentric shaft. Is not visibly having side arms. Okay, and here's the large gear that's also acting as a flywheel straight on the crankshaft, on the shaft of the crank. Okay. So again, select these and start working early on your project, we'll begin the chapter on kinematic analysis. So there will be additional theoretical material covered to where you can progress with your project. All right, so I said there are 17 steps, and up to selecting the motor would be for the midterm project. We don't have a spring break, so usually I had the project due after the spring break, so we need to decide around the middle, after you're done with the midterms, to have the midterm project report submitted. But you can start working on this part. So research the knowing design of slider crank punch presses in patents. I have after the page 3 of the project specification recommendation, which I say do not include this page with your report. And here I'm advising you how to Google what the keywords would be, the search words, including some links. Make sure you understand what you're referring in the introductory part. You search what others have done, what is out there. Make sure you're understanding, not just dumping it into your report to add pages, add volume to the report. Okay. And here are 2 screenshots, one of the Excel spreadsheet that you have to prepare, and the other one is for the working model simulation. Okay, I have the both up. So in red this is the way I organize it. So in red are the inputs, crank RPM, punch crank RPM or punch rate, and then for added flexibility, I have these in red as inputs. I can modify them, and then some calculated values. For example, omega based on RPM. That's very easy to understand what this does. Okay, and then the position, velocity, acceleration of the punch, and then this would be the pressure angle and its time derivatives. Okay, and towards the end, force at the punch, which will occur, it's a conditional force, occurs only when the punch is moving down and engages the stock, the corresponding torque. And using trapezoidal integration, you're going to calculate the average torque, and then the energy required to produce a punch, and with that you're going to calculate the flywheel. So you may want to watch this video maybe later on as you progress with your report writing and the calculations and analysis. Okay, so this is the working model simulation. I have some meters here that I can, it has maximum flexibility. I can move the stock in and out. And then there's, I ran the simulation several times. So it continues, and when this point it passes between the start punch, end of punch points, is producing a conditional force, so that acts only when the punch moves down, and has the shape as you showed, as you see it here. So maximum amount when the punch first touches the stock and goes to 0. And it's 0 when the punch just exited, and after that the workpiece. This is the velocity of the crank, shows this fluctuation. I'm going to ask you to calculate to confirm the coefficient of speed fluctuation based on this graph. Essential is for it to oscillate about middle position. I'm telling you now, we'll discuss this later. If this is moving up or slowing down, so if it's accelerating or slowing down, and it means that the calculated motor, that is the average torque that you come in from the Excel analysis, it's not properly calculated. This is either if it's small, it slows down. If it's too it's over than what you need is going to accelerate. This is a full equation that you would have to utilize in order to define that conditional force. I'm helping you out. So, and this is part of what I'm going to upload on Blackboard again. But you have to write this equation valid for the body and the points with their numbers. You may have other than 0.16 or 0.22, 23, but they are found here. Okay, so 0.22 position in the y direction, and then body 3, it'll be this one, velocity in the y direction. Okay, if it's less than 0, it means the downstroke. So if the body, the 3, that is the punch, is moving up, this will be a positive velocity, and nothing happens. Okay, so this is equation using formula language of working model. You have to implement it, and then for later on, for the final project report, you have to size a pinion shaft. The pinion is solid with the shaft, is not assembled to the shaft, has a keyway, places for bearings. You need to select those bearings, bearing at C, bearing at A, and this is the belt force, this is the gearing force, or the gearing forces, and you have to produce mechanical drawings, a complete mechanical drawing for the pinion shaft. Okay, I'm telling you what sample problems the book by Moth to follow, and it's towards the end, but I would recommend you to draw the full punch press at scale early on to where it's proportionate. So what you're seeing here, you have to draw it at scale. The crank at its given length, connecting rod of its given length, eccentricity as selected, and so forth. And likewise the sheaves at their diameter, center distance, angle according to the specifications. Okay, using AutoCAD versus drawing by hand. So in AutoCAD, you just draw it scale 1:1. Notations here shows current displacement of the punch, where the punch starts and when the punch finishes. You need to select these. Of course, they have to be when the punch finishes, has to be SF has to be less than S max. Okay, when the punch reverses motion. All right, so this is what I had to tell you at this point about the project itself. In terms of formatting, or rather, so yeah, you have indications or recommendations, grading criteria for formatting. But I know students, and this is an added part to this introduction. So I know students don't know how to use all of the important features of Word. Okay, so this button here highlights formatting elements. So this is I hit the Enter key, and I'm adding lines like on an old typewriter. Learned how to work with graphic images. I hate to see AutoCAD screenshots with black background. Learn how to copy vectors and paste them as Windows meta files rather than screenshots, and again, a lot of ink wasted by just printing the dark background. Learn to use, I click on the figure, I click here, and then picture format, and learn how to crop. Of course, I did this. They're all it's relevant information. But if you have unnecessary portions of your, if you want to, take just show just a portion of this, say you're using this tool, learn how to use. So click on the picture and the crop tool. Okay, what else? There are cases where you want to keep. I'm not going to save this. So you want to keep the caption, for example, to get, and it's already implemented here. I'm guessing. So let me double check. So okay, looks like so. There is an option, and I'm going to first take it off to make a point. So. Actually no, okay, that's fine. So let's see if I make this big, and all right, so what I want to say is that you want to keep the caption together with the figure, and this is I cannot undo it. I think I have it to where it behaves the way it should. So again, you if you want to keep the figure together with the caption, not separate them, one on one page, one on the next page, you click on the figure and you go to paragraph and you go to line and page break, and you click keep with next. This will turn this marker on. You see it only if you're in this mode, see formatting. And it's going again to keep the figure with the caption. Note that the figure captions are below the figures, and table captions are above, like you have it here. Well, I do not. Let's say if I want to have so call this table 1. Design parameters, and so I have 18 point spacing. Okay, make it small. Instead of 14, I make it 12. Okay, you also want to, so table caption or title goes above, figure caption go below the figure. If you want to likewise keep the, so I could have something like this. I could have the table title, caption, and the columns split between 2 pages. What you can do is just select all but the last row, and then you go to paragraph and you go to keep with next. Okay, and now they stay together. So make sure you do this to where your report looks pleasing to the eye. If you're to have, it's not my case here, but say if you want, and I would recommend for added resolution. So if you want to have, and like I said, I'm expecting you to illustrate your work with screenshots and graphic. So if you want to, let's see, rotate figure. Call line size layout. By the way, learned how to explore these features. Layout. Whether you want to, and this is usually when you put a figure in the text box. I don't know if I'm not expecting you to do that, but if you want to best use the printed space available, you can make figures small and put them in a text box. boxes. So, but I'm moving from the main subject I want to explain. So what I wanted to do is to rotate a picture. Maybe this is saved as an older version of Word. So say copy, I go to Paint, paste, and then select View. Okay, Home, select all, crops. Select all, crop. Okay. Select all, rotate to the left. Okay. Select all, crop. All right. So what do I have is, I should have prepared this ahead of time. Okay. So select all, copy. If you're to place it landscape in the page, all right, make sure it's oriented this way, not rotated like the way we have it here, 180 degrees. The best way though is to, now I realize the best way is just say layout, and you can make this the selection. So layout, page setup, and you can make it landscape for the selected text. Okay, so you have it here. You put for whatever. Make sure you label figures, so that somebody who's running their eyes through your report can, and likes the figures or is intrigued by a figure, can read what the figure is about. Okay, but have the orientation, and it was this later approach which is preferred, and I recommend you don't run into that situation. So again, I hate to see having to rotate in an unnatural way your report to where the pages that I just passed are towards my belly as I'm looking through I don't know if you get the idea. You can look through existing textbooks and reports, and they're essentially technical literature, see how they were organized, how figures or captions or graphs are introduced to the text. Okay. Lastly, there are instances where you want to keep, for example, if you want to keep text together between rows, you can do this. So what I did, I deleted the original space, and I'm press the Control and the Shift key, and then hit the space bar, and this will be a word. The space that's not going to break between lines. And then if you have a hyphenation that you don't want to break, then instead of the regular minus or hyphen, you just do the same, Control Shift and minus. All right, and these are not going to be separated on between rows. Okay. So learn to use equation. Insert, home, insert equation. I was about to demonstrate, but I don't have it available. So definitely, this was saved. This is an older version of Word. I could save it as in its latest format, and have the equation editor available. All right, so file would be file, save as, and then Word doc. Possibly, I don't know. I need to research why I cannot insert equations. Anyway, so this being said, I stopped recording. 25 minutes of recording. I'll post them for you, and there will be additional explanation as you move forward with the project. Again, the literature review and dimension selection, and to where you know what the crank length and connecting rod length, eccentricity of the slider crank are. You can do them like right now. Okay, so we stop recording.